Welcome. In this section, we are going to discuss the compilation process. Specifically, we'll focus on C. So first is we will look at what is compilation, what are the different stages in a C compilation. Second, the most interesting part, we are going to get hands-on into a Linux box. So we are going to look at preprocessor. Once that step executes, how is the output looking like? Second is from the preprocessor, when the compiler does its job, how does the ASM file or assembler file looks like? Then once the assembler step completes, how is the object file going to look like? And finally the executable. So we look at each stage and we look at the output of it. Then we'll get hands-on getting into C versus Java versus Python. We're going to differentiate and compare each of these compilations, right? So how does it happen? What is the difference? What are the different stages? That's what this video is about. Finally, we look at some quizzes at the end of the day. First topic, compilation process. So let's discuss the compilation process, the concept now. So the first step is called the preprocessor. So the preprocessor step is where the header files and macros and symbol substitution happens. This is the first step. So the second step in the process is compiler, where the compilation happens. The second step is the compilation. So in the compilation process, the pre-processed output is taken and an assembly version is .asm file is generated. So which is a assembly instruction version of the code. Third step, assembler. The assembler takes the input, which is the assembly file, and it converts that into the object code or .o. The linker takes all the .o files. As you know, right, in a single project, you could have multiple source files which are compiled. All the .dot files are .o files, which is the object files, are combined together, and the linker connects them all and it generates the final exe file. The linker is responsible to map the calling and called functions, right? It could be across files or it could be in the same file. It would also link the extern, right? The extern memory related files as well with the actual definition. That's the job of the linker. So we will look at each of these steps, right? The preprocessor step, we'll get hands-on. We'll open in a Linux system. We'll see how the preprocessed output looks like. We look at how the compiled output look like. We will look at how the assembled output looks like. And we will finally look at the linker operation as well. Let's get hands-on now. So we'll go to bella.org/jslinux. So if you search for JS Linux on the web, you will get this. So I'm going to use this Linux. You can use any one of these. So I'll just take one of these. So we can open a Linux terminal here and you will be able to see the output, right? So let's open a Linux terminal. So the Linux is loading for us and it will give us a bash window, right? So prompt window would come now. So we have reached the command prompt. Sometimes it could take a little longer. Let's list the files which are there in the directory. So you have a hello.c. Let's open the file. So I have a simple program here, right? So hello world, nothing else is there. So let's do one step at a time, right? So this is the file. Let me display the file for you. We are going to compile this file. GCC is the command to generate. So if you want to do GCC hello.c, it will generate the output, right? So this is the entire compilation process where it will do pre-processing, compiling, assembling, linking, and finally getting the exe file. Everything would be done and you will get the output if you do this command. So let's do that first and see the output and see what happens. Usually in Linux it does not take such a long time, but given that we are using a free compiler, it's taking a long time. So ./a.out. So I'm executing it. Yes, you've got the hello world. But this is not what we are looking for, right? This is the entire compilation process with all steps executed. What we want is, we want to just see the first steps output. So I'm going to say GCC -e hello.c. So -E is the one which is going to produce the pre-processed output. So I'm going to store it in a file hello.x. Let's do this. So now if you open hello.x, this will show the pre-processed output. So after the preprocessor runs, this is how it looks like. If you look at it, hash include stdio.h, whatever we had, the entire thing is expanded here. So this is the stdio.h content. So at the bottom of this entire thing, you will see the 4 lines of code which we actually wrote. These are the 5 lines of code, which is the actual code. Rest of it is from stdio.h. So let's just add one macro, right, so that I can show how that works as well. So what we'll do is I'll do a hash define max 100, right? I'm going to say int I equal to max. So this macro substitution also happens during pre-processing output. So gcc -e hello.c greater than hello.x. So now let's open this file. So we had a macro hash define. If you look at it, that is gone now. But int I equal to max was there, that has got substituted to 100. This is called macro substitution. That has also happened. So any literals that you have, that will get replaced during the pre-process stage. So this is the first step. So now what we have seen is the pre-processor output. Second step is the compilation step. So let's look at that. In compilation, the pre-processed output is given to the compiler, and the compiler compiles and it gives you a .asm file. Let's run that step now. So let's do the compilation step now. The switch is capital S, right? I'll do the hello.c. So actually I've taken the original source file and I've done the pre-processed output that is being fed to the compilation step. Now what gets generated is the ASM file. So it will be a .s file. If you look at it, it has generated the ASM file. So after the preprocessor, compiler is also run and the compiler generates this file hello.s. So if you look at it, this is the assembler code. This is an assembly language code looks like. This is specific to the processor, right? It will not run in any other processor. It's specific to this processor and the instructions in this processor. So you might see somewhere the string hello we have given, that will be stored as is. So if you look at it, yeah, the hello is there. Yeah, the string hello world is here. So it might be difficult to understand, right? Because there is a lot of use of these registers. So it will be difficult to follow the assembly language code, but you can rest assured that this is the assembly language code which is generated for this particular step. So now if you look at it, back to our PPT that we looked at earlier. So we have completed the preprocessor, we have completed the compiler, and the assembly language code is generated. Now this assembly to exe file, right, before the linker comes, let's look at that step now. So you have this code, I'll quit this one. If you do a gcc-o hello.c, what it does is it takes the source code, gcc-c hello.c. So it compiles, it generates the hello.o file. So if you look at it, so this actually takes the source code, it does a pre-processing, it does a compilation, it does a assembler as well. It invokes the assembler and generates the .o file. This is not an executable, but it is called as an object file, right? So if you try to execute it, you cannot execute this file. Even though it's an object file, you cannot execute it because it is just an object file. So the next step what has to happen is the linker. The linker has to get involved and it has to link this program and convert this to an executable file. So that's the next step that we are going to look at, right? I'll do a clear and we'll start this. So gcc main hello.c. Right, so this is the one which will execute everything. So it takes the preprocessor and after the preprocessor is done, it invokes the compiler. After the compiler is done, it invokes the assembler. After the assembler is done, it invokes the linker. And finally, the exe is generated. The exe is called a.out in Unix. So if you executed this a.out, you will get the output. So this is the full compilation process. So in this compilation process, the loader does not come in the compilation process. But when you do this ./a.out, that is you invoke the executable, loader loads that .o file, which is a.out file, into the memory. That's the job of the loader. So when you do this, only at that time loader is invoked. So this is the summary of the compilation process. Hope it was clear. Now that we have seen the compilation process, right? The actual interview questions could be something like this. Explain the compilation process. So you can explain the preprocessor, compiler, assembler, linker. What is the role of the loader as well? So that could be the first question. Second is, what is the role of the preprocessor? So we already saw what is the role of the preprocessor. It expands header files. It does literal substitution. It does macro substitution. That's the role of the preprocessor. Why is C program executable machine dependent? So if you look at it, the ./a.out when we did, it is specific to that particular machine. Why it happens? Because when a C program compiles through the process, right, when it converts to the compiler, during the compiler step, it actually converts to the ASM. That ASM is specific to a particular hardware. So you saw the ASM instructions which had %EAX and all these things, right? The registers. That's specific to that particular hardware. That's why the final output is machine dependent. So if you take that executable file and put it across in any other system, it will not work. But if you take the source C program, compile it again on another system and generate the output file, it would work fine. Only the executable, if you copy from one system to another system, it will not work. That's why we say C is not portable. What is the difference between a compiler and an interpreter? So C uses a compiler. So in a compiler, it converts the source code to an executable file all at once. After that, you don't need the source code. You can use the executable as many times as you want. You can execute and get that output. But in terms of an interpreter, Python, for example, uses an interpreter. So every line of code gets converted one at a time. So it takes, whenever you execute it, at that time it takes one line of code from the source, converts it in the machine language, and it executes that line. Then it takes the second line, it converts that code to a machine language, and it executes that. That's a interpreter. So we have already seen that in C. It's 5 steps overall. There is a C, actually the source code is taken, a pre-processing happens, then actually it sends to the compiler, the compilation happens, the compiler generates an ASM file which is or .s file which the assembler takes and converts to object code. The object codes are linked together and then the executable file is formed. Right? This is the process of compilation in C. And the loader, whenever the program has to be executed, the loader comes into action. The loader loads the memory into the text segment in the process space. So this is how in C it works. Now in C, the entire process is compilation. It happens at one step. Let's see that. So let's look at it, the compilation process in C. So we have a file called new.c. Very simple program, nothing major in it. We'll use Linux GCC to compile it. Whenever you do GCC new.c, it takes the source file, it compiles it, it produces the executable file. Executable file is the machine code. So whenever you run the machine code, which is the a.out file, it will run the program. So that is how C works. In C, it is a one-step process, and the key point is it produces the output which is specific to that particular machine. So the compiler is also specific to the machine, and it produces an output, the executable file, which is for the target hardware. If you run that executable in any other system, it will not work. It will work only in that particular system. And once you have the exe file, there is no way you can regenerate the source file, right? So this is how in C it works. So if you run it, here actually there is no output per se. We are not printing anything. But if there are errors in the program, in C, it will actually show you the errors. So if at all you want to create a file which has errors, say I have main and there is an error in the code that I have, some statement which is not there, the compiler will immediately show you the error as well, right? So it doesn't wait for the next steps during runtime. During the compilation process itself, the error is shown in C. So the error comes immediately. Error ASDFFA is undeclared, right? So when you compile it, immediately you will get the errors in C. This is how it works in C. Let's look at Python now. Python is an interpreter, right? It's an interpreted language. The difference between a compiled language and an interpreted language is, in interpreted language, each and every line in the program is translated to machine code only during the runtime. So let's see that in action. What does it mean, right? So it takes this print hello world. Let's assume I have another statement called print hi. There is no compilation step at all. It does not produce any exe file. So whenever you run the program, it takes first line, it does a compilation of it, it converts that first line into machine code, it runs it. Then it takes the second line, it does a compilation of it, it converts that to machine code, and then it runs it. So it does one line at a time, it converts the source file into machine language, right? So now if I'm running this particular program, let me run this code. So here hello world and hi happens. Let's assume there is an invalid statement here and I have I is equal to int of input. If you look at it, ideally in a C, if at all the same statement is there, it will say, hey, there is an error in this line of code. It will not generate an exe file. Let's see how it works in Python. So I'm running the code. There is no error at all. So it took this line, it converted that to machine code. It took this line, converted that to machine code. It took this line, it has converted that to machine code. It is waiting for an input. So if I type 222, this line will be executed. After that is done, only then it sees the statement. At that time, it will find that it is invalid. It will throw an error. Let's see that. So if you look at the code here, it has said invalid, right? So this is why Python is called an interpreter, because it takes one line at a time, converts that to machine code, takes the second line, converts that to machine code, third line converts that to machine code, and it executes, right? First line is executed, second line is executed, then third line is executed. After that, it converts the fourth line to machine code. So when it finds an error, only when it executes that line, it finds that there is an error, it throws an error. This is how Python works. Let's look at Java. So Java does a two-step process in the compilation, right? So the first step is called the compiler phase, right? Where you invoke something called as javac. So javac does a compilation of the code. If there is any error, syntax error, it will throw the error. If there are no errors in the code, it generates a file called abc.class. It is a bytecode which gets generated. So this is the first step in Java. Whenever you give the command java space the abc, whatever is the class name, java space abc, that time is just a execution, right? It does a class loader and then it verifies the bytecode that everything is fine. Then comes an interpreter where it takes one instruction at a time from the bytecode and it executes it in the machine or hardware, right? So this is how Java works. So every step it does separately. It does not do all the steps at one time. It takes one machine code at a time. It does a runtime translation to the target hardware and it runs it, right? So every line is interpreted after that. So Java is a combination of a compiler and interpreter. First stage is a compiler, which is javac, which converts to bytecode. Second step is a interpreter where it takes each statement from the bytecode and interprets it and runs it in the target hardware. That's how Java works. So the reason why Java does is it this way, Java is portable because the bytecode is common across all platforms. After that, the interpreter phase, it can. So with that, the first section, right, we have seen on compilation process. We'll get on with the second session. But before that, hope this explained to you very clearly how the compilation in C works. So we are going to go into the first question now. Preprocessor does the following: removes symbols from object code, converts source code to object code, compiles the source code to object code, expands header files and macros. So which one is the answer? You can pause the video, think about an answer, right? Okay, the answer is expands header files and macro, which is option D. We'll talk about this in detail in a very short time. The order of compilation is preprocessor, assembler, compiler, linker, linker, preprocessor, compiler, assembler, compiler, assembler, linker, preprocessor, preprocessor, compiler, assembler, linker. You can choose the option. You can pause the video. Okay, we can get to the answer now. The answer is D, preprocessor, compiler, assembler, linker. Again, when we discuss the video in detail, you will understand what it is. Third, loader is responsible for the following: loading source file into memory, loading executable into memory, loading compiler into memory, loading assembler into memory. So the answer is B, loading executable into memory. So these are three questions in the compilation process. Actually, even though we have talked about loader in the compilation process, loader is actually not a step within the compilation process. So let's get with question 4. Compiler compiles the source code one line at a time when the program is run. Option B, compiler compiles the source code all lines into an exe file when the program is executed or run. Option C, compiler compiles the source code and generates the binary exe file all at once. Fourth option is none of the above. Here the option is C, that's the correct answer. Compiler compiles the source code and generates the binary exe file all at once. That means the entire file is compiled and the exe file is generated. So hope you all liked the video. We looked at C compilation stages, the hands-on compilation different steps, and then we looked at the compilation process difference between C, Java and Python. If you have any comments, please add it to the comment section. Thank you.